Suppose you take any point P satisfies this equation, then you have to get the relation Pf1 plus Pf2 is equal to 2a. The distance F1, P4, F2, P4, the sum of those two will be always constant. So if you want y square here, you can shift x square by a square to the right hand side. So it becomes 1 minus x square by a square, and b square you can shift so that it will become multiplied. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In today's session, we are discussing about one more part of conic sections, that is ellipse. Now, what do you mean by an ellipse? So, ellipse is the set of all points in a plane whose sum of distances from two fixed points in a plane is constant. So you can see here, an ellipse has two distinct points which are called as focus. So it has two focuses. So that is when you add focus F1 P1 plus F2 P1. So this distance from the two focus will be same as F2 P2 plus F1 P2. Similarly, the same one F1 P3 plus F2 P3. So the distance of the two focus between any point will be constant throughout. So if you take other point also, the distance F1 P4, F2 P4, the sum of those two will be always constant. So therefore, it's a curve whose distance from two fixed points in a plane will be constant. So when you add the distance to this point from the two focus, it will be constant throughout all the points on the ellipse. So this is how we get an ellipse. Now, let's look at some of the characteristics of the ellipse. So here is an ellipse I have taken. So this is focus F1 and this is focus F2. So the midpoint of these two focuses is considered as the origin or the vertex of an ellipse. So, the midpoint of F1 and F2, which I have written as O, is considered as the origin or the center of an ellipse. So, the distance here between the two focuses, F1 and F2, is through the center is taken as C. So, that is distance from the center to focus 1, distance from the center to focus 2 is a constant and it is taken as C. Next, we have the intersection of the coordinate axis at 4 points. So, if you take this as A, B, C, D like this, the distance from A to center and center to C is same. That is, it is taken as A and OC is also taken as A. Similarly, the distance from O to B is taken as B. The distance from O to D is taken as B. So that is, everything is calculated from the center. So what we can conclude here is the distance between the focus, that is F1, F2, can be taken as 2C. And the distance of the vertices A to C or distance of the vertices AC can be written as 2A, and this is called as major axis. The distance between BD. So BD can be taken as 2B and this is called as minor axis. The center is always the origin. So focus can be taken as the coordinate. Here I can write the coordinate of a focus as minus C, 0 because it is at a distance C and it is on the negative side of the x-axis. Here I can take it as C, 0. So the vertices of A I can write it as minus C, 0 here, and for C I can write it as A, 0. Similarly for B I can write it as 0, minus B, and here I can write it as 0, B. Because both are at a distance B from the center, but one is on the positive side, another one is on the negative side. So therefore, it is at a distance B from the center. So I can write it as in the form of 0, b, because on y-axis x coordinate is 0, y coordinate has its value. On x-axis, x coordinate has its value, y coordinate is 0. So these are the coordinates of the vertices. Vertices are nothing but A, B, C, D are the vertices of the ellipse. F1, F2 are called the focus of an ellipse, and O is the center of the ellipse. So the distance of vertices on the major axis is at a distance A, and the distance of the vertices on the minor axis will be at a distance B. So therefore, what we can consider, the length of major axis can be represented as 2A, length of minor axis can be represented as 2B, and distance between the foci can be represented as 2C. So the next one is, we will study the relation between the semi-major, semi-minor and distance of the focus from the center of an ellipse. What do you mean by semi-major? So here, from A to C, it is called as major axis. Semi-major means it is half of the major axis, that is, it is OA or OC. Similarly, semi-minor means it might be OD or OB, that is half of the minor axis is nothing but semi-minor axis. Next one is the distance of the focus from the center of an ellipse. So here is the distance of any one of the focus from the center of the ellipse. It is always considered as C. This distance from the center is always C. Let's see what is the relationship between the semi-minor, semi-major and distance of any one of the foci from the center. So we have a relation, that is C square is equal to A square minus B square. Okay, where C is the distance of the focus from the center of an ellipse and A is the semi-major axis and B is the semi-minor axis. So this is the relation between them. Now here we have two cases. So what are the cases we have here? I can consider it as case 1. Suppose here if C is equal to 0, what does equation become? We get A square is equal to B square. If this is 0, I can shift B here, so it becomes A square is equal to B square. This implies what? A is equal to B. So if A is equal to B, what happens? So this is exactly the ellipse we may get like this. So this is the maximum distance A and this is the minimum distance B. If both are equal, what happens? The distance A and B are same. So then you will get a circle. So an ellipse can become a circle if the semi-minor and semi-major axis is same. That is, if A is equal to B, an ellipse become a circle. Next one, we have one more case, that is case 2. Suppose C is equal to A. If C is equal to A, what happens? We get A square is equal to A square minus B square. I can cancel A square on both sides. So I will get B square is equal to 0, which implies B is equal to 0. If B is equal to 0 means there is no semi-minor at all. So we'll get a straight line which is at a distance A. If there is no B means B value is exactly 0. So then there is no ellipse. We will get a line segment which contains only semi-major axis. That is, we get a line segment where B is equal to 0. Since B is equal to 0, it will be at the origin. So we doesn't get any curve there. So this case, in the case of C is equal to A, the ellipse becomes a line segment. Next, we have one more concept called eccentricity. So what do you mean by the eccentricity? Eccentricity of an ellipse is nothing but it's a ratio of the distance of the foci from the center to any one of the vertices. What are the vertices of an ellipse? The vertices of an ellipse lies on the major axis. So therefore, here you can consider A or B as the vertices of an ellipse because it's a major axis and it is at a distance A here. So here also it's at a distance A. So therefore, what I can consider? It is equal to distance of the foci. From the center, we represent it as C and it's a ratio. Therefore, it should be in the form of C over A. So, therefore, eccentricity of an ellipse can be calculated using the relation E is equal to C divided by A. Now, let us consider the standard equation of an ellipse. So, you have a 6 marks question as the standard equation of an ellipse. So, you will get in a part E section where you will attend the 10 marks in the form of 6 plus 4. So, the question 50 might always be the derive the equation of an ellipse in the form of x square by a square plus y square by b square is equal to 1. So, for that we need one diagram and the procedure. What is that? Now, consider the focus F1 and F2 whose coordinates are minus c comma 0 and c comma 0. Why it is taken as minus c comma 0? Because the distance between the foci from the center is always c. Since it is on the negative side of x-axis, we write it as minus c comma 0 and for this we take c comma 0. Now let us take any point on the ellipse. So, now A, B can be considered as the major axis, C, D is the minor axis. Now, let P be any point on the ellipse. Let us write what we have taken. Now, let F1 and F2 or the foci. O be the center. The line, so this is the line through the focus F1, O, F2 be the x-axis. Next, the line perpendicular and passing through O, passing through O be the y-axis. Next, let the coordinates of F1 and F2 are, F1 is we take it as c comma 0 and F2 we take it as minus c comma 0. Now let us take any point P on the ellipse. So let P of x comma y be any point on the ellipse such that the distance between PF1 plus PF2, the distance between PF1 plus PF2 is equal to 2a. Now considering this as an assumption, we have to prove that this is the general equation of the ellipse. So let's see that using the distance formula, we can write this as square root of x minus of minus c becomes x plus c whole square. Next y minus 0 whole square becomes y square plus again square root of x minus c whole square plus y square is equal to 2a. Now I will rearrange this. I will take this as x plus c whole square plus y square is equal to 2a minus square root of x minus c whole square plus y square. Now to remove square root on both sides, let us square it on both sides. So squaring both sides we get here x plus c whole square plus y square. And here it becomes 2a minus square root of x minus c whole square plus y square whole square. Now here let us see what we will get here. X plus c whole square as it is plus y square is equal to, when you square this you will get this as 4a square. So here without the square root you can write. So you will get x minus c whole square and here plus y square minus, because this is in the form of a minus b, so this is a square plus b square minus 2 into 2a into root of x minus c whole square plus y square in the form of a square plus b square minus 2ab. So on simplification here, we can shift here root of x minus c whole square plus y square is equal to a minus c by ax. Now again we have a square root here. Again to remove the square root, let us square it on both sides. So squaring on both sides, you will get it as x minus c whole square plus y square is equal to a minus c divided by x whole square. Now again you have x minus c whole square plus y square is equal to a minus c by a x whole square. Again substituting all the values, expanding and simplifying, we will get the equation as x square by a square plus y square divided by a square minus c square is equal to 1. Now I can write this as x square by a square plus y square divided by b square is equal to 1, where b square can be written as a square minus c square. This one we have a relation between the semi-major, semi-minor and foci from the center. So we have this relation. So using this relation, I can replace a square minus c square as b square. So thus we have obtained the standard equation of the ellipse. So by considering the condition PF1 plus PF2 is equal to 2a. So if PF1 plus PF2 is equal to 2a, then we can conclude that the general equation of an ellipse is x square by a square plus y square by b square is equal to 1. Now let us take the converse part. Now let us consider this as the equation. Let us prove that PF1 plus PF2 is equal to 2a. So now let me consider this as a standard equation. Let us assume the given ellipse satisfies the general equation, that is the standard equation, x square by a square plus y square by b square is equal to 1. Now conversely, let p of x comma y satisfies this equation with 0 less than c less than a. Now, if you rearrange this equation, you will get y square is equal to b square into 1 minus x square by a square. So, if you want y square here, you can shift x square by a square to the right hand side. So, it becomes 1 minus x square by a square, and b square you can shift so that it will become multiply. So, you will get y square is equal to b square into 1 minus x square by a square. Now, let us take the square root of PF1. Now therefore I can write PF1 is equal to square root of what I will get here, x plus c whole square plus y square. Now let us substitute the value of y square here. So when you substitute the value of y square here, it is x plus c whole square plus here it is b square. This becomes a square minus x square divided by a square. Now again on solving this, I can write x plus c whole square is equal to b square can be written as a square minus c square using the relation. So using this relation a square minus c square, here we have a square minus x square whole divided by a square all under the square root. Now we have x plus c whole square, a square minus c square, a square minus x square divided by a square. So solving this inside the square root, you will get an equation a plus cx by a whole square under the square root. So square and square root get cancelled. You can write this as a plus cx by a. So this is what PF1 you get. So now you got PF1 is equal to a plus cx divided by a. Similarly, you can find PF2 using the relation x minus c whole square plus y square. So what you will get then? We can get PF2 is equal to a minus cx divided by a. Now we have got PF1 as well as PF2. Let's add PF1 and PF2 here. So now let us take PF1 plus PF2. So if you take PF1 and PF2, you will get the value as A plus CX divided by A, plus again you will get it as plus A minus CX divided by A. So you can cancel CX by A plus A is equal to 2A. So we have got PF1 plus PF2 is equal to 2A. So the converse part of the relation is also true. So that is, when you have taken the equation PF1 plus PF2 is equal to 2A, you will get the standard equation as x square by A square plus y square by B square is equal to 1. So that is the standard equation of an ellipse. Now suppose you take any point P satisfies this equation, then you have to get the relation PF1 plus PF2 is equal to 2A. So we have got PF1 plus PF2 is equal to 2A. Hence, the theorem is proved. That is, the standard equation of an ellipse is x square by A square plus y square by B square is equal to 1. Now, let us look at the derivation once again. We have derived the equation of ellipse in the form of x square by A square plus y square by B square is equal to 1. So here, what we are supposed to take? We have to take an ellipse with focus F1 and F2. So we have to take a straight line passing through the focus F1 and the center O F2, that we will consider it as x-axis, and the line perpendicular to x-axis passing through the center is considered as y-axis. Write the coordinates of F1 and F2. Next, let us take, let P be any point on the ellipse whose coordinates are x, y. Now let us assume that we have PF1 plus PF2 is equal to 2A. By assuming this, we have to show that the standard equation is x square by A square, y square by B square is equal to 1. So let us apply the distance formula to calculate PF1, PF2 because we have a coordinates. So assuming that we will get the distance formula, x minus of minus c becomes x plus c. So therefore it is x plus c whole square plus y square, and this is x minus c whole square plus y square is equal to 2A. So now shift the second term to the right hand side, square both sides, squaring, and on simplification we will get the equation as x plus c whole square plus y square is equal to, here you get in the form of a minus b whole square formula. So this is a square plus b square minus 2ab. On simplification, we will get the right hand side as a minus c by ax, and left hand side this can be shifted here. It becomes x minus c whole square plus y square. Again squaring on both sides to remove the square root. This can be written without the square root, and the right hand side become the square of the term. So again simplifying, we can reduce the equation as x square by a square plus y square divided by a square minus c square. We have learned the relation, that is a semi-major, semi-minor, and the center of the foci can be related using c square is equal to a square minus b square. But we have got here a square minus c square, that can be replaced with b square. So replace it back. So we will get the standard form of the equation. So by assuming the condition, we got the standard equation. Now let us prove the converse part. Let us assume that this point satisfies the standard equation. Now let us prove the constant distance from the two foci will be equal to 2a. So for that, consider the standard equation. Just find only the value of y square. So to find the value of y square, replace x square by a square to the right hand side, then multiply with b square. Apply the distance formula for PF1. So if you apply the distance formula for PF1, we get x plus c whole square plus y square. Now substitute the value of y square here, and we also know that b square can be written as a square minus c square. So solving each term under the square root, we will get the value as a plus cx by a whole square. So since it is under the square root, it cancel. We will get the term a plus cx by a as PF1. Similarly, we can find PF2 is equal to a minus cx by a. Now our aim is to add that and find the constant term. So let us add PF1 and PF2. Cx by a minus cx by a get cancelled. We will get the value as 2a. So the converse part is also true. So therefore, what we can conclude, the standard equation of an ellipse is x square by a square plus y square by b square is equal to 1. So in today's session, we have learned what is an ellipse and its characteristic and a standard equation, that is, you have a 6 marks derivation for your examination. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.